The physical world of AI, data centers, energy and the cloud. Where does AI live? Every time you ask artificial intelligence a question, a physical event happens somewhere on Earth. Not in theory, not in software, in a real place, using real energy. This is the story of where AI actually lives. There is a word we use every day, and it quietly lies to us. The cloud. When you save a photo, or ask an AI a question, you imagine your data floating somewhere above your head. Clean, light, invisible. But the cloud is not in the sky. It is on the ground, and it is heavy. The cloud is made of concrete, steel, copper, glass, and electricity. The cloud is a network of enormous fortresses called data centers. They are hidden in fields, in deserts, in industrial zones, from Virginia to Ireland to Singapore. Some of them are as large as football stadiums. Inside them, thousands of machines work without rest. The rooms are kept near a constant 20 degrees Celsius. The sound never stops, a permanent storm of cooling fans. Entry requires biometric checkpoints and guarded perimeters. These are among the most protected civilian buildings on Earth. They glow, they roar, they burn with heat. So much heat that they need rivers of cold air and water just to survive. But these fortresses are not anonymous. They have names, and they have addresses. For example, one of the largest concentrations of data centers in the world is in Northern Virginia, United States. This region is operated at a massive scale by Amazon Web Services. In the industry, this region is known simply as US East 1. A very large part of the world's internet traffic flows through this single area. In Ireland, one of Europe's main digital hubs belongs to Microsoft. Its major campus near Dublin serves cloud and AI services for customers across Europe. Only a few kilometers away, another giant operates its own fortress. That is Meta Platforms. Its Irish data center supports the systems behind Facebook, Instagram, and WhatsApp. Across the Atlantic, in Oregon, in the United States, Google runs one of its flagship data center campuses. This is where a large part of the search, cloud services, and AI infrastructure is processed. And in Nevada, Apple's massive data center supports cloud services, backups, and user data for hundreds of millions of devices. These buildings look quiet, but inside them, tens of thousands of servers run every second. In this episode, we will follow a single click and discover what really happens, physically, when you ask an AI a question. The undersea journey. Let us try a simple experiment. Imagine you are sitting in a cafe in Manila or in Tel Aviv. You open ChatGPT and you type, "Give me a recipe for chicken adobo." The moment you press send, your question does not fly into space. It moves to a nearby cellular tower. From there, it enters a fiber optic cable buried under your street. These cables are made of glass strands thinner than a human hair. Your request becomes light. It races toward the coast. And then, it dives into the ocean. This is the part most people never picture. The internet is underwater. Huge cables, as thick as a garden hose, stretch across the floor of the Atlantic and Pacific Oceans. Your question swims past rocks, shipwrecks, and deep-sea darkness, thousands of kilometers, in less than a second. And finally, it rises on another continent and enters a building, a fortress, a data center, and it stops inside a single metal box in a single room in a single building where the computation actually happens. The factory floor. This is where your question arrives. Welcome to the home of artificial intelligence. Inside this building, it is loud. The air shakes. Thousands of fans scream to keep machines from overheating. The air smells of hot electronics. Your request reaches a specific computer, a special accelerator chip, often a GPU. Think of this entire data center as a giant restaurant kitchen. Your message, chicken adobo, is the order ticket. The data center is the kitchen. The chip is the chef. But this chef is not cooking only for you. It is cooking for millions of people. At the same time, your order arrives. The chip wakes up and begins to generate an answer. But here is the strange part. The chef does not know what adobo tastes like. It has never smelled garlic. It has never touched vinegar. So how does it write a recipe? The answer is not stored inside the machine, it is generated. The super autocorrect. The secret is something called a large language model. But you already use a tiny version of it every day. Look at your phone keyboard. When you type, "I am going to the," your phone suggests the next word. Store, office, park. It is guessing. Not because it understands you, but because it has learned what words usually follow other words. And I like chat, GPT works the same way, only at a massive scale. It has read recipes, blogs, menus, cookbooks. So when it sees chicken adobo, it does not search for truth. It predicts. What word usually comes next? Soy sauce, then vinegar, then garlic, then bay leaf, then peppercorns. It predicts the answer one word at a time. Thousands of predictions per second. So fast and so accurately that it feels like intelligence. But at its core, it is the most powerful fill-in-the-blank machine ever built. The cost. This invisible thinking has a very real price. Human brains need food. Artificial brains need electricity. They also need water. Many facilities pump thousands of liters every minute just to carry away heat. Every time you ask an AI to write a recipe, a small wave of heat is released inside that data center. A cooling failure can destroy machines worth millions in minutes. Sensors constantly search for microscopic leaks before humans could ever notice. Some systems now circulate liquid directly across the processors. A single drop in the wrong place could destroy hardware worth millions, so the buildings constantly monitor pressure, humidity, and microscopic changes in airflow. A normal web search is light. It is like switching on a small flashlight. An AI conversation is heavy. It consumes many times more power, and when you ask an AI to generate an image or a video, the energy used can be comparable to charging a smartphone. Once, multiply this by millions of users, by day, by night. Right now, technology companies are buying electricity on a scale normally reserved for cities. Some are even reviving nuclear power plants, just to feed these machines. The clean cloud is becoming one of the hungriest energy consumers on Earth. The energy demand is growing so quickly that some companies are already signing early agreements for a new kind of power called fusion. Fusion tries to produce electricity the same way the sun creates light, by combining tiny atoms and releasing enormous energy. Not because it is science fiction, but because today's power grids may not be enough to support the future of AI. The migration. For years, technology followed a simple belief. Everything should live in the cloud. But artificial intelligence is changing that idea. AI moves enormous amounts of data. Sometimes moving the data costs more than computing it, so the machine is beginning to spread. Hospitals keep medical AI inside the building. Factories run inspection systems next to the assembly line. Cars cannot wait for the internet before braking. Instead of one distant brain, intelligence is dividing into many smaller ones. Part of it remains in massive data centers. Part of it lives inside company servers. Part of it now runs directly on your devices. Engineers call this hybrid and edge computing. The cloud is no longer a place. It is becoming a hierarchy, from continent to city, to room, to pocket. And the body of AI is changing as well. New chips are being designed not for graphics, but for thought. Some are built to run with minimal electricity. Some even try to compute using light instead of current. The machine is still growing, but it is no longer only getting bigger, it is getting closer. Conclusion. Now you know what the machine really looks like. It has a body made of glass cables and silicon chips. It has a brain that predicts words instead of thoughts, and it survives on enormous rivers of electricity. But the machine is no longer staying inside distant fortresses. Not because the centers are shrinking, but because intelligence is spreading outward from them. It is no longer confined to the data center. It is moving into hospitals, into cameras, into cars, into phones, into human decisions. So the real question is no longer, how fast can the machine write a recipe? The real question is this: what happens when a probability machine is asked to predict something far more important than dinner? What happens when it is asked to help decide what you see, what you believe, and what you do? In the next episode, we open the toolbox, the toolkit, how humans build and use AI. Because the biggest secret of the artificial age is simple. The power is not only in the machine, it is in the tools we give it, and the choices we make while using it.